Okay, so this is the Edexcel A-Level C1 paper from May 2015, and we'll begin question 1. And the first question, part A, is to simplify 2 root 5 all squared. So let's begin that. So part A, 2 root 5 all squared, and that's the same as 2 root 5 times 2 root 5. And if we do that, we could do 2 times 2 is 4, and then root 5 times root 5, that will be root 25. And then we can simplify that. We get 4 times root 25, which is a 5. And finally that becomes 20. Okay, part B, we've got this surd, and we want to simplify it, put it into form a plus root b. So let's copy the question. So root 2 over 2 root 5 minus 3 root 2. And what we do here, we're going to multiply top and bottom by 2 root 5 plus 3 root 2. So this is rationalizing the denominator. So 2 root 5 plus 3 root 2, and 1 on the bottom, 1 on top. 2 root 5 plus 3 root 2. And then we can work this out. So we'll do the top first. So root 2 times 2 root 5, that will be 2 root 10. You multiply the root 2 and the root 5 to get root 10, plus root 2 times 3 root 2, that will be 3 root 4. 3 root 4, and that's all over the first term, 2 root 5 times 2 root 5, that will give you 4 root 25. And then the outer term will give you 6 root 10. So plus 6 root 10. The inner term gives you minus 6 root 10. And then the last term should be minus 9 root 4. 9 root 4. Okay, so let's simplify this. In the numerator, we have a root 4. That's really a 2. So it's going to be 2 root 10 plus. So that's 3 times 2, which is a 6. Okay, and at the bottom, we have a root 25. That's really a 5. So it's 4 times 5 is 20. The 6 root 10 and the minus 6 root 10, they cancel, they disappear. And then we have a root 4, which is a 2, so it's 9 times 2 is 18. So that's a minus 18. So equals, and we can simplify this. We've got 2 root 10 plus 6 on top. At the bottom, we've got 20 minus 18 is a 2. And since there's a 2 common in the numerator, we can divide both of them by 2. So 2 root 10 divide 2 is root 10, plus, and then 6 divide 2 is 3. And that's the final answer, 10 root 3, root 10 plus 3. Okay, question number 2. And this is a simultaneous equations, non-linear. We have one linear equation on top and a non-linear equation at the bottom. So the method here, we're going to make y the subject in the top in the linear equation. So we're going to get, we'll bring the minus 2x and the minus 4 to the other side. That will give us y equals 2x plus 4, and then we're going to substitute this equation into the second one where the y squared is. So we get a 4x squared plus, and here's the y squared, we're going to substitute this in for y. So 2x plus 4 all squared, and then we have the plus 20 equals 0, plus 20x equals 0. Okay, and now we have an equation, a quadratic equation in x, so we have to simplify this. We'll first work out this term underneath first of all. So 2x plus 4 all squared, that's a double bracket. So I'll just work that part out first. So let's expand this. So you've got first is 4x squared plus, then you have the outer terms, 2x times 4 is 8x, then the inner term 4 times 2x is 8x again, and then the last is 4 times 4, which is a plus 16, and this simplifies to 4x squared plus 16x, that's the 8x and 8x is 16x plus 16. Okay, so let's replace this with this, and let's just copy it out from the beginning. So we'll now just continue on over here. That follows on from there. So we get 4x squared, that's that 4x squared, plus all of this, which is over here. So we'll copy that, plus 4x squared plus 16x plus 16, and then we have a plus 20x equals 0. Equals 0. And now we'll just collect like terms. We have 4x plus 4x squared plus 4x squared, that's 8x squared. And then 16x plus 20x, that's 36x. And we have a 16 left over equals 0. Okay, so we have to solve the quadratic, and the first thing we notice is that there is a common factor. We can divide everything by 4. So let's do that. Let's divide both sides by 4. So we need to divide each term by 4. So this becomes a 2x squared plus 9x plus 4 equals 0. And this we should be able to factorize. So this turns into a double bracket. And 2x squared, so we better put a 2x and an x. And if we do some trial and error, we have a 4 here, so it's either a 2 and a 2, or a 1 and a 4, or 4 and a 1. And we can probably just by sight guess that it must be a plus 4 to give you an 8x on the outer, and a plus 1 to give you a 1x on the inner, so 8x plus 1x is 9x. Okay, and now we can solve this quadratic. So we'll split it up. 2x plus 1 equals 0. And x plus 4 equals 0. And we'll solve both of them. So the first one gives you 2x equals minus 1. And therefore x is minus a half. So that's the x solution. And we have to get the corresponding y coordinate. So if we go back up, we need to substitute minus half, x equals minus half, into y equals 2x plus 4. So let's substitute that in. So we get y equals 2, and we put in the x plus 4, and this gives us 1 plus 4 is a 5. So that's the first solution, x equals minus half and y equals 5. And for the second solution, we'll solve for x. X equals minus 4, and again we'll substitute that into y equals 2x plus 4. So we get y equals 2 and x is minus 4 plus 4. So that gives us minus 8 plus 4 is minus 4. So the second solution is x equals minus 4 and y equals minus 4. Okay, so question number 3, and this we're given a polynomial y equals 4x cubed minus 5 over x squared, and we need to differentiate it and also integrate it. So the first step is that we're going to rewrite this without the fraction. We're going to get negative indices instead. So if I rewrite that, we get y equals 4x cubed minus 5x to the minus 2. And now we can do part A. We want to differentiate, so dy by dx. So the rule is the 3 is going to come down and multiply the 4. So 3 times 4x, and we minus 1 off the power gives us a 2. Then we have minus, and the minus 2 comes down, minus 2, and that multiplies the 5, and we minus 1 off the power, give you minus 3, and then we simplify this. So 12x squared, minus and minus gives you plus, so that's plus 10x to the minus 3. Okay, part B, we want to integrate. So the integral of 4x cubed minus 5x to the minus 2 with respect to x. And let's do that. So we have 4x, and we add 1 to the power, gives us 4, and we divide by the new power, minus 5x, and then we add 1 to minus 2 to give us minus 1 over minus 1, and we have a plus c, and then we just simplify. So 4 and 4 cancel, we have x to the 4, we have minus 5 divided minus 1 is plus 5, and then x to the minus 1 plus c. That's the answer. And question number 4 is iteration, and we're given an iterative sequence. So to get the next term, you do 2 times the previous term minus the term before that. And we're given u1 and u2, and we need to get u3. So let me write out the iteration formula for the third term. So u3, according to this, should be twice u2 there, and then this is u1, so then minus u1. And let's do it over here. So that's twice u2, which is a 4, minus u1, which is also a 4. So this gives us 8 minus 4. It's 8 minus 4, and that equals 4. So u3 is 4. The next thing we want to do is work at the sum of the first 20 terms. So basically what this means, it means u1 plus u2 plus all the way up to u20. Now, it turns out, if you can see this, that all the terms are equal to 4. u1, u2, u3, u4 up to u20 are all 4. And we can see this because if u1 and u2 are 4, and they gave us the next term as a 4, that means u4 will be based on u2 and u3, but they're also 4. which means that u4 will be 4. So that means all the terms are equal to 4. So this is none other than 4 times, and there's 20 of them. So 4 times 20, and that's 80. Okay, so part 2, there's another sequence, and it's defined actually by the same formula. So it's twice the previous term minus the term before that. But this time, instead of the first two terms being 4 and 4, we're given k and 2k. So we need to get v3 in the third term and the fourth term. So let's begin part A. Let's get v3. So according to the iteration formula, v3 is twice v2 minus v1. And we'll substitute those in. So twice v2, which is 2k, minus v1, which is k. So that equals 4k minus k, and that equals 3k. And then v4, according to the iteration formula, will be twice v3 minus v2. So if we substitute those in, that's 2 v3. Now v3 is 3k minus v2, which is 2k. And we'll simplify that. So that's 6k minus 2k. That gives us 4k. So we have v3 is 3k and v4 is 4k. The next, we want to work out part B, the sum of the first 5 terms. So sum n equals 1 to 5 of Vn. Well, we don't want to work it out. We're told it equals 165, and we're going to use that to work out k. So this is shorthand for v1 plus v2 plus v3 plus v4 plus v5. So we already have up to v4. We just have to work out v5 first of all. So let's do that first. So v5 should be twice the previous term, which is v4, minus the term before that, which is v3. We'll substitute in. So v4 is 4k minus v3, which is 3k. So this equals 8k minus 3k, which equals 5k. And now that we've got that, we can now make an equation. We can add up v1 to v5 and set it equal to 165. So let's do that. So v1 is k, so it's going to be k plus 2k plus 3k plus 4k plus 5k, that's v5, and this all equals 165. Okay, so now we can simplify this. So 5 plus 4 is 9, plus 3 is 12, plus 2 is 14, and plus 1 is 15. So we get 15k is 165. Therefore, k should be 165 divide 15, which equals 11. And that's done. Okay, question number 5, and we're given an equation. a quadratic equation, and we're told it has no real roots. And so this is a discriminant question. Part A, show that p satisfies p squared minus 6p plus 1 is greater than 0. So let's do that. So part A, we're told it has no real roots. So basically that means the discriminant, b squared minus 4ac, should be negative. And let's just write out what a, b, and c are. So a is the coefficient of the x squared. It should be p minus 1. B is 4. And c is p minus 5. And we'll substitute these three in for a, b, and c over here. So b squared minus 4, this is a and c, and that's less than 0, and then we just have to solve this inequality. Should be a quadratic inequality, so let's expand everything first. So 16 minus 4, and we'll just expand this. So that's p squared, and then we get minus 5p minus p, so that's minus 6p, and then we get a plus 5 less than 0, and now we'll expand this. 16 minus 4p squared, and then minus and minus is a plus, so that's plus 24p, and then minus 20 is less than 0. And now we'll get, we better get everything, we'll just simplify all of this. Collect like terms, so minus 4p squared plus 24p, and then 16 minus 20 is minus 4, less than 0. And here we notice that there's a common factor of 4, but also if you look at the original question, we want it to be a p squared, not a negative p, so we're going to divide it all by minus 4. And when we divide by a negative number, we have to flip the inequality. So this is going to become greater. So if I divide that by minus 4, you get positive p squared. Divide that by minus 4, you get negative 6p. And this you get a plus 1. We flip the inequality, and 0 stays a 0. And that's part A. And part B, they want us to solve the inequality. So let's do that. So part B, and this, it doesn't look like it's factorizable, because at least with whole numbers or fractions, because of the 1 here. It won't work out, so we better solve this, maybe using completing the square. So let me complete the square on this, or we could use quadratic formula. So we want to solve the following. So it's p minus 3 all squared minus 9 plus 1 equals 0. So you get p minus 3 all squared equals, and we'll bring the 9 and the 1 over. That will give us a positive 8. And now we will square root both sides. So p minus 3 equals plus minus root 8. And then we'll bring the 3 over. So we get two solutions. P is plus and minus root 8. 3 plus and minus root 8. Okay, so let's do a little picture. We can see that p is positive, so it is going to be a positive quadratic. It will look like this, and we can draw it here. And it doesn't really matter if we don't do it too accurately, but I think these are both positive because root 8 is less than 3. because 3 squared is 9, so 3 minus root 8 is still positive, so I think both roots are positive, so I'll just draw it like this. That's the quadratic. This is the first root, 3 minus root 8, and this is the second root, 3 plus root 8. And if you go back to the original inequality, we want it to be greater than 0, that's above the x-axis. So a hollow circle, because it doesn't include the 0, going that way, and a hollow circle going that way. So this is the solution on the number line, and now we can get the actual solution. P is less than 3 minus root 8, or P is bigger than 3 minus root 8, 3 plus root 8, and that's the final solution. We could, of course, root 8 is also 2 root 2, but it's not, doesn't really matter. You could have put 2 root 2's instead, but that's fine. Okay, question number 6. We're given a curve, and there's the equation. And we first want to do dy by dx. We want to differentiate it. So the first thing to do to differentiate this is that we're going to just expand out the top and cancel the 2x if possible. So let's see. So y equals, so let's just expand the numerator. So x squared and x is x cubed. Then we have the outer term is minus 3x squared. The inner term is plus 4x. And the last term is minus 12. And this is all over 2x. And we are going to split up the fraction, so I'll do it in 2 steps. It's x cubed over 2x minus 3x squared over 2x, 4x over 2x, and minus 12 over 2x, and then we'll just simplify this. So this is going to be 1 over 2 x squared minus, and this is 3 over 2 x, and here 4 over 2 is a 2, so that's plus 2, and the x's cancel, and then 12 over 2 is a 6, and over x is a x to the minus 1. Okay, so that's y, and now we can differentiate it. So let's get dy dx. Okay, so the 2 is going to come down and multiply the half to give you a 1, which I won't write. We'll just put it, and then the x, the 2 becomes a 1, so that becomes an x. A linear term, the x just disappears, so it's minus 3 over 2. Constants disappear. And for the final one, the minus 1 is going to come down and multiply this minus 6 to give you plus 6. And then we'll minus 1 of the power to give you a minus 2. So that's dy dx. And part B, find an equation of the tangent at the point when x is minus 1. And give the answer in that form. Okay, so we need to get a point and a gradient. Let's keep that there. So first of all, when x equals minus 1, we better get the y coordinate first. So let's substitute minus 1 into the original equation. So we get minus 1 cubed minus 3 minus 1 squared plus 4 minus 1 minus 12, that's the numerator. Then over the denominator, that's that's 2 minus 1, and we can work this out. That's minus 1. This is a 1, because if you square the minus 1 you get a 1, so that's minus 3. That's a minus 4, and minus 12. Over the bottom is a minus 2, so we get minus 12, that's minus 16, minus 19, and that's minus 20. So minus 20 over minus 2 is positive 10. Okay, so we've got a point. The coordinate is going to be the coordinate minus 110. Now we need to get the m, the gradient. So let's substitute minus 1 into the derivative to get the gradient. So that's dy dx equals minus 1 minus 3 over 2 plus 6, and we'll put minus 1 in there, and we'll work this out. So that's minus 1 minus 3 over 2, that's minus 5 over 2. And this is a positive 1, so that's plus 6. So we have 6 minus 5 over 2, I think that's 12 over 2 minus 5, it's 7 over 2. And this is going to be our gradient, so we've got a point is minus 110, and m, the gradient, is 7 over 2, so we can now do y equals mx plus c. And let's substitute m first. So we first get y equals 7 over 2 x plus c. And now we want to work out c. We had better plug in x and y. So y is 10. So 10 is 7 over 2 times minus 1 plus c, which is equal to minus 7 over 2 plus c. So we get c equals 10 plus 7 over 2, which is equal to 27 over 2. So we're now ready to get the equation. I've got room down here actually. We now know c is 27 over 2. Let's just plug that in. So y equals 7 over 2x plus 27 over 2. And we want to get it in the following form: ax plus by plus c equals 0, where a, b and c are integers. So if there's any fractions, we have to remove them by multiplying by the denominators. So we'll multiply everything by 2, each term by a 2. So here we get 2y equals, that becomes a 7x, and that becomes a 27. And lastly, we'll just get everything to one side. So 7x minus 2y plus 27 equals 0. Okay, question number 7. And we're given that y equals 2 to the power of x. And we want to express 4 to the x in terms of y's. So let's do that. So we have 4 to the power of x. So what we're going to do, we want the base to be a 2. At the moment the base is a 4. And we notice that 4 is 2 squared. So we're going to replace the 4 with a 2 squared. So that's it. So that 4 is 2 squared, and that x is that x there. And now, using the rules of indices, this is the same as 2 times x, 2 to the power of 2x. 2x. And if we want, we can actually swap, or even here, we could have just simply swapped the x and the 2. That's allowed. Because 2 times x is the same as x times 2. So this is 2 to the power of x, all squared. So these are the same, because 2 times x and x times 2 is the same as 2x. And then the thing in the bracket, this 2x, is y. So this equals y squared. So the final answer then is that 4 to the x is equal to y squared. And part B, we then want to solve this exponential equation. Okay, so let's begin. We see that we have a 4x there. We can replace the 4x with y squared, and we can replace the 2x with y, and we're going to end up with a quadratic. So we're going to get 8y squared minus 9y plus 1 equals 0, and we'll solve this quadratic. So let's see if it factorizes. It's a double bracket. It's either an 8 and a 1 or a 4 and a 2. I'm going to go for an 8 and a 1. It looks like that would work. So let's go for an 8y and a y. That gives us 8y squared. Because that's a 1, we can really only have 1s here. And we should be able to see that it is in fact minus and minus. Because this gives us minus 8y, minus 1y is minus 9y. So that equals 0. We'll split this up into 2 equations. So 8y minus 1 is 0. That gives 8y equals 1 and y equals 1/8. And the second one is y minus 1 equals 0. That gives us y equals 1. So they're the two y values, but the original equation was in terms of x. So we have to go back to the substitution that we used. Now, I didn't write it down, but the substitution that we actually used was y equals 2 to the x. That's what we were using. So let's use this. Let's put the y values in here and solve it for x. So the first one, if I just switch the equation around, it's 2x. There's 2x equals y, so it equals 1/8. And let's see if we can solve this. So 8 happens to be a power of 2, so we can write this as a power of 2. That equals 1 over 2 cubed, which equals 2 to the minus 3. So we can see that x must equal minus 3. That's one of the solutions. And the other solution, we get 2 to the x equals 1. And this only has, well, you can put this as a power of 2, I suppose. It's 2 to the 0. Anything to the power of 0 equals 1. So we know that x must be 0 as the second solution. Okay, question number 8, and we're given a cubic and we need to factorize this. So let's do that. So 8, question A, we've got 9x minus 4x cubed, and the first thing we should notice before we try anything else is that there is a common factor. There's an x common to both sides, both terms. So let's pull out the x. And then we end up with 9 minus 4x squared. So that's a quadratic. And it turns out that this is a particular kind of quadratic. It's a difference of 2 squares. So we should know that. I'll do it straight away. It should be, well, this is 3 squared, if I just put that in small. And this is 2x all squared. So the factorization should be 3 minus 2x and 3 plus 2x. So the final answer is x, then bracket 3 minus 2x, and other bracket 3 plus 2x. So that's the factorization. Part B, they want us to sketch this, and they want us to put the x-intercepts. So where it meets the x-axis is the x-intercepts. So the first thing we want to do is to get the critical values. So that's when this thing is set to 0. Let's just do that first. So x, that, and that equals 0. And this we can split up into 3 separate equations. The first equation is x is 0. The second one is 3 minus 2x equals 0. And if we solve that one, I think we get x is 3 over 2, which I can put as 1.5. And if we solve for this third one, so 3 plus 2x, and that gives us x equals minus 1.5 minus 3 over 2. And the last thing to point out is that this is a negative cubic. So the general shape of it would look like this. So this is a negative cubic that way. And now we're ready to draw it. Okay, down there. So negative cubic, and we have a negative solution, a positive solution, and passing through the origin. It should look like this. Passing through the origin, and then there. So this is minus 1.5. That's the origin. We don't need to mark anything there. And this is 1.5. That's done. And part C, we're given 2 points A and B. They lay on the curve, and they have x coordinates minus 2 and 1. And we want to find the length between the 2 points, and it's in the form of k root 10. So the first thing we need to do, we need to work out the actual coordinates of A and B. So let's do that. So A is when x equals minus 2. We need to substitute that into the original equation to work out the y coordinate. So that's 9x minus 4x cubed. I'll just write it over here. So let's just substitute minus 2 into there. We end up with y equals 9 minus 2, 4 minus 2x cubed. So that's an 18, minus 18. This is a minus 8 times minus 4 is positive 32. So that equals 14. Yep. So we have the coordinates of A. It's minus 2, 14. So that's somewhere on the picture. It's somewhere over here. If we were going to put it in, don't have to, but that's where it would have been. The next coordinate, x is equal to 1. So x equals 1. We're going to substitute that in to here. 9, 1. 1 cubed. So that's a 9. That's minus 4. So it equals 5. So we have the coordinates of the point B is 1, 5. So that was somewhere maybe around here. And we want to get the length AB. And we can use the distance formula for that. And I'll just write out the distance formula. The distance should be the difference in x coordinates all squared plus the difference in y coordinates all squared and then all rooted. Okay, so let's work that out. So length AB, and let's substitute these 2 points in here. So the difference in x coordinates, it's minus 2 minus 1 all squared plus 14 minus 5 all squared, then all rooted. So I'll just work it out this way. So that's minus 3 squared, and this is a 9. So we get 9. Minus 3 squared is 9 plus 81 all rooted, and that's root 90. And we can split up the surd. that's equal to 9 times 10, so that's root 9 times root 10, and that's a 3, so this is 3 root 10, and that's the form they want it in, so we know that k must be 3, therefore k equals 3. Okay, question number 9, and this is arithmetic progressions, and we're told that Jess started work 20 years ago. In year 1 her salary was £17,000 and it goes up by £1,500 per year. So let's just get that down. We know the first term A is 17,000 and the common difference D is 1,500, and we'll better just write down the main formulas we'll be using. So the first formula is the formula for the nth term, un, that's a plus n minus 1d, and the sum of the first n terms is n over 2, 2a plus n minus 1d. Okay, so we're told that in year K she earned £32,000 and we need to work out K. So UK sub U sub K equals 32,000, and we're going to replace UK with our numbers and K. So let's replace UK with this formula where A is 17,000, D is 1,500 and N is K. So we end up with A plus K minus 1 D should equal 32,000, and we can now solve this for K. So let's minus the 17,000 over first. So that's 32 minus 17 is 15,000, and now we can divide by 1,500, so that equals 10, and then we can add 1 over, so K is 11. And part B, they want us to work out the total amount earned in 20 years. Now we have to be a little careful here because the answer's not S20, because her salary doesn't go up and up and up. On the 11th year it remains the same. So for part B, we have to work out S11. That's what she earns in the first 11 years. We'll do that first. So S11 equals n over 2, which is 11 over 2, there. And then 2a, so that's 2, and first term 17,000, plus n minus 1, which is 10. And D is 1,500. So let's work that out. So it's 11 over 2, 34,000 plus 15,000. And that's, I'll write small now, 11 over 2. 34 plus 15 is 49, so that's 49,000. So we need to divide that by 2 and times it by 11. So it's 11 times, and we can half that. That's 24,500. And let's just do the multiplication. So 245 times 11 is 245. And another 245, and then we have to add on 2 zeros, Okay, so in the first 11 years, we know that she earns £269,500, but we want to know what she earns in the first 20 years. So there's 9 years remaining, and we're told that her maximum salary was 32,000, and once she hit that, it remains the same. That means for the remaining 9 years, she earns 32,000 per year. So we have to do 32,000 times 9. So 32 times 9, 27, 28. And we have to, it was 32,000, so we have to add 3 zeros on. So the total she earns should be 288,000 plus 269,500. Let's do that over here. 288, that. So let's add this up. 0, 0, 5, 7, carry the 1, 14, 15, carry the 1, it's 5. So the final answer is £557,500. Okay, question number 10. And we need to work out the function f of x given its derivative and a point it passes through. So this will be integration. So let's begin that. So part A. So the first thing we need to do before we integrate this is to prepare it. And we'll get rid of the surds and put it in index notation. So here we have f dash of x equals, so it's 3 over 2, and root x becomes x to the half, minus 9 over 4, and we have an over root x, and that's the same as x to the minus half, and then plus 2. And now we're ready for integration, so let's integrate. So the integral of all of this equals, so it's 3 over 2 x, and we add 1 to a half, that gives us 3 over 2, and then we divide by the new power, 3 over 2, minus, so 9 quarters x. If we add 1 to minus half, you get a positive half, so that's x to the half, and 2 becomes 2x, and we have a plus c, and then we'll just simplify. So the 3 over 2 cancels with the 3 over 2, so we're left with x to the 3 over 2 minus, I forgot to divide by the half here, so there should be an over half over there. So we have minus 9 quarters divide a half, that's the same as 9 quarters times 2. So here we get minus 9 halves x to the half plus 2x plus c. And now we can work out what c is. We're going to plug in the point 49. So 49, that's our x and y coordinate. So we end up with y, or rather 9 equals 4 to the 3 over 2 minus 9 halves 4 to the half plus 2 times 4 plus c. So this simplifies to 9 equals, now power of 3 over 2 means you take the square root and then you cube it. So if you root 4 you get a 2, and then 2 cubed is an 8, minus 9 halves, and 4 to the half, that's root 4, which is a 2, plus 8 plus c. So let's bring the the 8 and the 8 over. So 8 plus 8 is 16, and then 9 minus 16 is minus 7. And then 9 halves times 2 is a 9, so that's minus 9 plus c. Therefore, if we plus the 9 over, we get c equals 2. So the final answer should be f of x equals x to the 3 over 2 there, minus 9 halves x to the half plus 2x plus c, which is a 2 plus 2. Okay, part B, we're told that there's a point P that lies on the curve, and the normal to the curve at P is parallel to this line here, 2y plus x equals 0. So let's just draw a picture first of all. Part B. So we've got the curve. It doesn't really matter what it looks like, but you've got a point P. And there's the normal. The normal is perpendicular to the tangent, so that's a right angle. And we're told that that normal happens to be parallel to another line there, and that was the line 2y plus x equals 0. 2y plus x equals 0. And we want to get the x coordinate of P. So the first thing we do, we better get the gradient of this line. We can do that by rearranging for y over here. So 2y equals minus x, then divide by the 2, y equals minus half x. So we know that the gradient of this line is minus a half, which is the same as this gradient. So this is also minus a half. Therefore, we know we have the gradient of the tangent. It should be the negative reciprocal of the normal. So the negative reciprocal of minus half is positive 2. So this gradient is equal to 2. So we can simply now we can find the point where the gradient equals 2 by setting the derivative equal to 2. So let's go back to get the derivative. So 3 root x over 2 3 root x over 2 minus 9 over 4 root x plus 2. Plus 2, and we're going to set that equal to the gradient of the tangent, which is a 2. And we can now solve this for x. So the 2's will cancel, and we'll plus this term to the other side. So 3 root x over 2 should equal 9 over 4 root x. And we can solve this by cross multiplying, multiply that there and the 2 over here. So 4 root x times 3 root x is 12 root x, 12x equals, and 2 times 9 is an 18. Therefore x is 18 over 12, and we can divide by 6 top and bottom to give us 3 over 2. And that's the end of the paper.